talk about JWTs, JSON Web Tokens, and it's the newer way of authenticating you that you are who you are from your web app. And traditionally, we've used just a regular token. The problem with using just a regular token is that token is associated with the user, and it will always be that same token with that user. And so if that token ever gets exposed to anybody else, they can say that they are you and do things on your web app as you. The advantage with a JWT is that you can have it expire, and it will renew the JWT, and after it expires, and the old JWT will no longer work. So we've implemented that into this Canvas starter app here. And so a little background on the JWT here is a nice little tutorial on it showing what a JWT is. And this is what it looks like. You've got 3 sections here, and it breaks it down here as the header, payload, and signature. So the header is, you've got what type of algorithm that the JWT is. Then you've got the payload, whatever you put into it, and then you've got the signature that kind of wraps it all together. It says, okay, this is that. And so if anything changes in there, the decoding the JWT will fail. And so it's a really secure way of doing this. So we've got in the project, we've got the JWT for the gem, and that gives us a couple methods for doing this. Here we've got the 2 methods for encoding and decoding your JWT. And so when you encode it, you give it a payload, you give it a secret, and this can be your regular secret key, or you can make a new one, and then you give it the algorithm type. And here we have that algorithm type HS512, which is the HMAC, and it's 512 encryption, SHA encryption. You can do even greater encryptions, but it requires you to keep track of a public and a private key. So it just depends on how much security that you want to incorporate. I just went for the simple, use the one secret to do the encoding and decoding. Now, I've integrated this into Devise. So when you sign into your account, the device, it'll send off the request to the sessions controller. And here, this is the regular Devise methods, but instead of just doing this is the regular Devise right here. We're going to take it a step further and send back some JSON with your JWT, with your JWT inside of that. So before that, we come in and we say, okay, issue a token. We give it a user ID, which is our user ID. This auth token comes from here, which is just a library I've stuck into the lib folder, and it issues the token. You give it a payload. Say, okay, expire at this time. Default I've got is 24 hours, but you can send in, if you want it to just go 2 weeks or 4 weeks, however long you want. And we give it some sort of client ID. Doesn't really matter, I don't think. In this case, it could be whatever you want. And that's the part that's going to be kind of important when we decode it, and I'll show you that. So then we go ahead and encode it, and this sends it back. and we render that JSON, or that JWT in the JSON. It comes back to the server. You can see here we got that JWT, and it looks like that. We got the 3 sections. They come back in, and that gets stored off into the React app, and I'll show you that in a second here. And from that, anytime you need to do anything, you use that token in your app. When you use that token, it comes in. Well, maybe I'll go over to the React stuff first. So when it comes back from the login, we've got our login action, comes back into here, dispatches the login stuff here. Okay, and let's see here. Sorry. So here we have it coming back from with that JSON. Here's the payload from that JSON coming back into the app. We call the login function here, and we grab that JWT out of the payload. And I'm just going to store it into local storage into your browser here. And that way, anytime if they open up a new browser window, it'll still be in local storage. So you've got that JWT sitting there available for use. And so anytime you need to make an API call here into our API methods here, I've got setting the JWT as an authorization into the header. So now, if you want to do any of these API calls, it sets your JWT into your request, comes back over here to into the Rails app, and so here's a controller where I've done this. I implement it extending the secured controller here. And so anytime any request comes into this accounts controller, so in this case, just for the index controller, it's going to go to here first, validate this before action, that JWT is inside of the header as an authorization. It grabs the token out of there. It decodes it using this auth token inside of the auth token methods here. Decodes it, and if it's valid, comes back into here, says, okay, yeah, you're good to go. If not, it will raise this invalid token. And here's where that AUD comes in, is important. It just looks at the client ID or whatever you set it to from here. This AUD looks at that and says, okay, is this the same that they got set into the JWT beforehand? And if it's not, then it raises the invalid token. Or if this gets decoded, if this gets decoded and it fails to decode properly, it'll hit this rescue and say, sorry, that token's no good. So there's kind of two checks to make sure that your token is a valid token. So when it does that, if it succeeds, then it will go ahead and give you the stuff that you're requesting through that controller. Comes back, everything's good. If not, it'll come back and reject it, saying, sorry, you're not allowed. Does anybody have any questions on it?
So one question I had as you're walking through here, you've sent it to 24 hours.
Mm-hmm.
It seems like, or at least it feels like, maybe this is similar to a session token from a traditional web application. Would I maybe want to just set it to 20 minutes and then somehow refresh that token every 20 minutes? Because I don't want it to log me out if I'm still using the application, but at the same time, if it's a token that can expire and that I just need to get a hold of one of these at my next login, maybe I would want to set it to expire after 20 minutes, and then maybe give the user an option to say, keep me logged in, and I would set it to 2 weeks or something at that point.
Yeah, that's entirely up to you, and that's what I would suggest doing, is saying, hey, log me in, keep me in for 2 weeks, and then you don't have to worry about it after that.
Okay. And these tokens are signed via the encryption algorithm or via the hash. Let's see, go back to your different algorithms. You chose, what,
It's the 512.
Okay, so it signs this payload and sends it down to the client, but the client doesn't ever decrypt them.
No, the client just keeps a hold of this JWT,
right,
and sends it back saying, hey, I'm authorized, here's my key. And the server just decrypts it and says, okay, yeah, that's a valid key. And if you look...
So somehow in that header piece, the header is the first thing on the left, the client can decipher that is... I guess it doesn't decipher anything. It just sends it back, and then it lets the server handle ensuring that the token hasn't been modified. The client doesn't do anything other than just pass it back and forth.
Correct. So here's an example where you got this key and it's valid. It's, everything works. But if I change one thing, it says, "Nuh-uh, that's been changed. I don't think so. You're not going to be changing that on me."
Right.
So there's nothing anybody can do to change anything that goes into this signature.
Okay. And then as long as you pass these back and forth over SSL, you're fine. You wouldn't want to pass them in the clear, because then somebody could snoop the token and use this token to interact with the API.
Correct. For as long as it's valid, anyways, they could. Yeah.
All right. And then you had mentioned something about symmetric encryption, where you have public-private keys.
Mm-hmm. And if you wanted to do that, you can go with this RSA or the ECDSA, and you generate your public and private keys, and you keep track of those and whatnot. So it's just higher level of security if you need it.
Okay, but even in that case, it seems like both the public and the private key would still be stored inside of the Rails application.
That's what I presume as well.
Because you would still need, I think you'd need access to both of them to handle signing and then verification.
Yeah, so you encrypt it using the key object, and then you decrypt it using just the public key.
Right. But every time you generate a new token, you have to have access to the private, and then to decrypt it, you have to have access to the public.
Correct.
Okay. Okay. Excellent.
Does anybody else have any questions? Cole, I know you have a question.
No.
No? Okay.
I agree with Justin that if this is something that we're going to put in our main projects, that we should go ahead and update it so that it is refreshing that token, right? So that because that's the standard behavior of the units, right?
Yeah.
Yeah, you want it to somehow refresh the token. As long as the user is interacting with the API, you want it to continue to refresh that token. So we should look in the documentation and see if that is something that they provide, like as part of the gem, somehow.
I don't think so. I think it's something you have to roll your own on your own, and just in your React app, just say, hey, every 20 minutes, go get you a new token.
And I guess that's because the actual expiration of the token is stored in the payload.
Mm-hmm, it is.
Okay, so click back on your auth_token.rb there. So you have expiration.2i, so that's where that happens. So in that case, maybe what you have to do is each time you respond via the API, whenever you send a response to the client, maybe you also issue a new token. Although that might seem expensive.
If you get a lot of API calls, though, that could really
get really expensive. So maybe then another way to do it would be to have the React application recognize that it has received a token, and at the same time, as part of that payload, you could also send it an expiration time. And then the client could set a timer to re-request a new token before that time is up.
Yeah, that would work.
So it would pass the old token and say, I need to exchange this old token for a new token. And then as long as everybody's clocks are in sync. You probably wouldn't want to give it an absolute time. You'd probably want to say this thing expires in X number of seconds. And then let the client app set the timer for that number of seconds. And then they could or just less than that number of seconds. And then have it re-request.
Yeah.
Or could you just put some code in that place where you're inserting that token every time? If it comes back unauthorized, could you automatically just at that point redo the request?
You could redo it, but it's going to make the user log in again because your login session is essentially gone at that point because your token is expired. So then that would be forcing the user to. It would pop up the login message every 20 minutes and ask them to re-authenticate, which would be kind of painful.
Yeah, so you needed to do it more as a preventative thing instead of after the fact.
Yeah, you have to do it within the window where that token remains valid. Because other than that,
yeah, I'm just trying to think about what security that actually provides for you. Because, like, maybe you could use the old token to generate a new token.
Well, I think that as soon as the old token is about to expire, right? So you've got you have the exact same window of time that to use that token. So if it expires after 20 minutes, then that's a hard deadline. You can't add more time to it without generating a new token because the token is signed, right? So modifying it invalidates it. So what you do is you say, my token is about to become invalid, but the user's still here and still using the app. So I'm going to, or the app is still open, like as long as it's still open on the page, then you send up the request to the server and say, give me a new one of these, and the server generates a new one with a new expiration time and signs it, passes that back down to the client, and it's good for another 20 minutes. So if somebody were to snoop the old token, it would be valid until that expiration time, but it would be a matter of like 30 seconds of overlap where two tokens are valid.
Yeah.
Something like that. The whole single-page app authentication is actually somewhat complex because you are dealing with sessions and you need to know how long should I keep this person logged in. Like if their computer goes idle for an hour, should I kick them off? And how do I know that it's truly idle? And in other apps like TherapyMate, we've popped up a message and asked the user, do you want to stay logged in? But in a lot of other applications, I don't know that we want to keep asking the user to stay logged in. I think we want to just keep them logged in. The other complicated part is that frequently with a single page app, you're doing things that may not make a call back to the server. Like if you're really good at making your application performant and you can store data client side, you might not be calling the API. And so while the user is doing things inside of the client, the server may think that they have gone away. So you have to have a mechanism for saying, no, the user is still here, they're still active on the app. Don't kick them off. Don't expire this session. Otherwise, everybody gets annoyed by logging in.
Anybody else?
Okay, thank you much, James.
I guess to respond to Joel as well, this doesn't prevent somebody from getting your key and continuously refreshing it. But if somebody does get your key and tries to use it after it's been expired, then it will stop them in their tracks. Whereas the previous method of just using a regular token that never changes, they'll be able to use it no matter what. So. Anyway. Okay. Nobody else has any questions? We'll say goodbye.
All right. Thank you much.
Thanks, James.
You're welcome.